Welcome to CSC 21. No, sorry, CSC 31 and lecture 21. Okay, so this will be the third part of our CPU design. And I think this lecture will be very important to your final exam on Saturday. So please pay attention and to this lecture, and I'll have office hour on Thursday for you to ask questions about what to do with that kind of problems that you see. So I'll mention about what you need to or what to expect on your Saturday exam. Okay, so as I go through the lecture, okay, so stay tuned. Okay, all right. You have turned in your project 2 already, and starting from today, and today is actually my recording day, Tuesday. Um, I will ask your TA to get ready for your demo. So make sure that you go to your lab and demo your project to your TA. And I will send your code to your TA after the similarity test. And they should have a copy of your code and then run your code already. Okay. So, and what happened is that they will look through your code, run your code, and check the expected component, whether it prints out the statement correctly, whether your program reads the user input correctly. And then finally, I will give them a couple test cases to check the accuracy. So which means that if your program doesn't produce correct results, doesn't mean that you automatically get a 0. Okay, as long as you at least fulfill those instructions, like the requirements, like read in from the user, print out statements, and print out correct statements. For example, the repeating statement, right? You have how many bars and you have how many bars, right? So as long as the structure is correct, you get some points, all right? But of course, the calculation is very important too. So that's why I would prefer that you have the complete working program so that it's easier for your TA to grade at least. Okay. And also the similarity test, very important. I see some of you just add extra lines, empty lines to your program. That won't pass the similarity test. So if your code is very similar to others, doesn't matter whether you change your variables or just add extra lines, the similarity test will still detect it. Okay, just unfortunately that you try to do that. So, but again, your TA, I will let your TA know um, uh, what scores you get from the similarity test that will raise the flag. Okay, so when your program raises a flag from the test, then your TA will ask extra questions, okay, about your work. Okay. And the last homework is homework 8, and it's due next Friday. And I know this is way after your final exam, but I would hope that you can finish it um, this Friday. Okay, so treat it as a practice because this really will help you. And as you do your reading assignment, okay, I know it's due tomorrow, right? So just try to try out the activities, the challenge activity as you read, right? So then you have a better understanding. But again, the assignment is due next Friday. But again, you can try that earlier. And as I mentioned, you have the last reading assignment that is due tomorrow, Wednesday. And here is the list of exams that we'll have. Tomorrow, Wednesday, we'll have our exam on floating point numbers and integer numbers. So I had the office hour yesterday discussing the content. So what you can do is to watch the video. I know I forgot to press the record button at the first maybe 10 minutes, but I kind of go over the same thing in later part already. So you should be able to find out what to do with that, find out what to make up with the first 10 minutes. And just make sure that you go to CAT courses to download the notes so that you see what's going on. Okay? And again, I'll ask not only floating point numbers, but the integer numbers that we talk about in midterm 1, right? So like the conversion between zeros and ones to base 10 in different representations, like unsigned integer, signed integer, including ones complements, twos complements, bias. So make sure that you're aware of the conversions between all those, okay? And on Saturday, we will have 2 main exams, and each exam probably will be split into, I would say, maybe 2 exams. So expect like maybe 4 exams so that you have an appropriate time on different types of problems, okay? So the first big group exam is on CPU, which is the one that I just mentioned. And most likely I'll ask 2 questions. Okay, the first one will be the digital logic, which is from a truth table, how do you come up with the logic gates, okay, the combination of the logic gates. So I'll go over that example again in this lecture. Okay? So that's the first portion of the problem. And the second portion will be the data path, giving you an instruction. How do you draw the data path, trace the data path, and then give me the control value. And I'll go over that in more detail in today's lecture. So that's why make sure that you study today's lecture, okay, over and over again until you are familiar with the setting. And then the second portion of the final exam on Saturday will be on C. Okay, so pretty much it will be like any topics in C. Okay, so I gave you the practice exam already. So I will ask memory management things, and I will ask simple C code. Okay, so or ask just like your midterm one, right? Giving you the code, what would be the expected output, something like that. Okay, so study that, and I would expect you to be able to answer those kind of questions. So that it can be code writing, it can be fill in the blanks, it can be multiple choice, it can be true false. So any option. So I'll test the understanding, the concept of C programming in relation to the CPU. Okay, so how machine works. Okay. So again, I will have office hours on Thursday, and tentatively will be from 10:30 to noon. And I will send an announcement later today or tomorrow to confirm that. Okay. All right. So last lecture, at the end of the lecture, I talk about this topic, right? Giving you the truth table. How can you come up with the digital logic, the combinational logic circuit, right? To describe that, right? I have 3 input, A, B, C. I have 3 pins of input. So you can say this is like a big box, big black box, right? You have 3 inputs. So let me draw it out. So today my pen works now. Finally, I'm so glad. Okay, so what happened is that I was using an old version of Office, Microsoft Office 2013, and it is the known issue that in the presentation mode, the pen just doesn't align. Okay, so I have to reinstall my Office to the newer version. Okay, so now I have 3 inputs basically. So 3 inputs and go through the weird black box, and it turns out the output. So kind of like a function, right? If you learn function in algebra, f of y, right? No, actually, y equals to f of ABC, and the ABC, the function is described by the truth table. Okay, so how do we do that? So the way to do it is to use canonical form. Okay, so all we need to do is locate all the rows with y equals to 1, because we want y to be true, right? In what occasion the output is true, and then locate that. Okay, so whenever you see the input as 0, you put a bar or the complement of that input. Because when you have input 0, right? When the input is 0, take the complement, what do you get? You get a 1. When you have a b equals to 0, take the complement, you get a 1, right? C is 0, take the complement, you get a 1. And when you have 1 and 1 and 1, you get a 1. And so that's the whole concept of canonical form, or sum of product. When you do the AND operation, you want to make sure that the result is 1. And when you have all of them, either one of them is 1, you get the y equals to 1, right? So that's why you have the OR operator. So when I have something, or something, or something, or something, right? And when one of them is true, right? Then you have the whole output equals to true. So that's the whole idea of canonical form. Okay, so locate all the rows when y equals to 1. Okay, and then put put the input. When input is 0, you just put a not. Okay, so for your exam, okay, so be careful, right? For your exam, you can't really type bar on top of it. Okay, so there's no way you can do that with the CAT courses. Well, maybe, but I don't expect you to do that. So what I want you to do is to do something like this. Okay, just like your coding, just put, in this case, I want you to put not a, and someone try to join my meeting and I don't have any up, so I don't care. So I need to get it. How do I remove that? Okay, so I guess it's not sharing anyway. Okay, so not A, not B, not C, plus not A, not B, not no, not C. So don't even put a dot in front, okay, in between. So you don't need that, just without dot, okay? And then plus A, not B, not C, plus A, B, not C. Okay, so this is how you would enter. Sounds good? So I want you to make sure that you follow this instruction. Otherwise, the auto grader will treat your answer as wrong. Then that will be devastating. Okay, so make sure that you read the instruction very, very carefully. I should have give you, the time I give you should be enough for your problems. Okay, so just calm yourself. Okay, so because any stress won't help, right? So just take your time, okay, and just calm yourself down. Then it should help you, okay, concentrate. Okay, so make sure you do that. Okay. All right. So now once you do that, okay, so the next step is to perform the simplification. Okay, so I went over that in the last lecture already, so I'm not going to talk too much about that. Okay, so I want to quickly go to the next example. Okay, so now you have something like this, right? So in your answer, if I ask you to draw, well, of course you cannot draw, right? So I'll figure out how to make this work. Okay? But anyway, so if in case I ask you to draw or something, then either way is fine. Okay, so it will be a manual graded portion. Okay, so this is an example. And I've noticed that in the video from last lecture, it was wrong because I think I missed one row. And that's why the answer is not correct. Okay, so what should we do? Okay, so here, since I can draw on this line, so it will be a lot better. Okay, so make sure that when you work on your problems on a piece of paper in your exam, copy, double check, triple check your question before you work on it. Okay, when you copy your question. So first step, what does that do? I will locate all the rows with output equals to 1, right? Output equals to 1. So now let's write the answer. Okay, so again, I will use the convention as if you type in your answer. So I will use, instead of using the bar, I will use the not. Okay, so I will have what? O equals to not A, not B, and C, right? So this is the first one. How about I do that here? Not A, not B, C. Okay, how about this one? Not A, B, C. So far so good. How about this one? A, B, not C. Sounds good? So now all you need to do is just to write them out. I have not A, B, C, plus A, B, not C. So make sure within the product, don't put any operator. Don't even put a dot in between, okay? So don't do that. Don't put not A dot not B dot C. So don't do that, all right? Because if I use a fill in the blank, and it will be automatically graded. So if you put a dot, then the result is not the same as my solution. Then the system will treat it as wrong. So just read the instruction carefully. Okay. So now what's next? We will do the simplification, right? So pick any common terms together. So from here, looks like I have one. From all of the three terms, pick the common term that you can factor it out, right? So for example, I can take not A and C. Okay, so what do I have? Again, no dot operator, okay? So just copy it. And then I have what? Since I take out not A and B out, I mean not A and C out, I will have not B. And then plus, for this one, I have B. Sounds good? So I have not A and C. Not A and C. Okay, so, and then plus A, B, not C. So there's no common block here. And what do I have? Oops. Okay, so now I have one. Not A, C. So this is just identity, right? Because you have not something or something, you get one, right? And then plus A, B, not C. And I guess that's pretty much it. And you can't really take out anything. Okay, so that's it. So now draw the answer. I have 2 and operator, right? Because you only have 2 terms. Okay. And what do I have? I have not A. So I have an A and then put a dot, that becomes a not, right? And then I will have a C here. How do I do that? Maybe I put a B here and a C here. Okay. So my C will go here. Okay. And then the second one, I will have, oops, too sensitive. Okay, so now I have what? A, B, and not C. So I would have not C, B. Okay, so maybe I should make it clear that it's not touching the C line, okay, just like your circuit drawing. Okay, so if you take circuit design class, yeah, the engineering 65, you'll learn something like this, okay? And then I have A, right? So A cross B, and you got that. Okay, so this will be your not AC, and this will be your AB not C, and now you have 2 output, and then now you draw the OR gate, and now this is your O. Sounds good? So this is the correct answer. So the last lecture's video, because I copied the table wrong, so I had the wrong answer, but the idea is the same. Just locate all the rows with output equals to 1, and that's it. Okay. All right, so let's go back to your data path. So this is the data path that you need to pay attention for your exam. Okay, so giving you this data path, how do you trace individual instructions? So this is the focus of today's lecture. Okay, and then in the last lecture, next lecture will be your last lecture, lecture 22, and we'll go over the control. Okay, so how to come up with those control values. Okay, but now we're just focusing on manually come up with a control. Okay, so from here we will see several components here. Remember how many stages it takes for the CPU to execute an instruction. Remember that? How many stages? Okay, count your fingers. Okay, so 5 fingers, right? So one is instruction fetch. So review from last lecture. So first I have instruction fetch, and then instruction decode, and then ALU, right? Or sometimes we call it execution. Okay, and then memory. So if an instruction is using a memory, lower storage, you use that, right? And then finally, what do you get? You get the write back. So write back is to write the result of either ALU or memory, if it's a low word, back to a register. Yeah, so the result of ALU and memory doesn't go to register right away during the ALU stage or memory. It waits until the last stage and write back to the register. Okay, and this data path show all these 5 stages. Okay, so to divide that, I can do something like this. Okay, to illustrate that, this is your yellow is too yellow. Okay, so let's use green. Okay, this is your instruction fetch unit. Why? What does instruction fetch do? Instruction fetch takes in the address, right? PC is your address, the address of your instruction, the zeros and ones, right? And then go to the instruction memory, which is a cache or a memory, that's fine, doesn't matter. Okay, but in CPU, we always use cache because, again, as I mentioned, memory is just too slow, right? And so that's why you want a copy of your memory resides in your computer, in your CPU. So you go to the memory, fetch the instruction, right? So you have a 32-bit instruction, okay? And then what do? You take the same address and go to the adder and add 4 to it and prepare for the next instruction. And it's not there yet, okay? So you just add 4 to it, that's all, okay? And we're gonna decide whether to use that as my next address later because we don't know the instruction yet, okay? At this stage, we only fetch the zeros and ones, that's it. It doesn't know, the computer doesn't know, okay? At the end of this stage, the computer doesn't know what it is supposed to do, okay? All it does know is I have a 32-bit instruction, that's all. So this is instruction fetch. Second stage, let's use another color. Second stage will be what? Instruction decode, right? What does that mean? Decode means to understand what it does, right? So ID, I should put them together. So decode has a big stuff, right? So decoding is what? You understand what your instruction does and something like this, okay? So this is ID. I know it's kind of messy, right? So what does it do? It decode your instruction. What does that mean by decoding your instruction? Just like your last exam, giving you an instruction in zeros and ones. Give me the MIPS instruction, so that the CPU understand what it's supposed to do. Okay, so how do you do that? Well, the first 6 bits tell you what format it is, right? And once you know the format, you know how to partition, whether you have RS, RT, RD, or you have RS, RT immediate, or just the branch, not the branch, but the jump label, right? So by doing that, you know what to expect. And then what? Not only you know what to do, but you get the data ready so that you're ready, you're ready for the ALU stage. So what does that mean? Since I know the operand, if it's an I format or R format, I'm going to operate something, right? So I'll prepare the RS, RT, or I'll prepare just the RS and immediate, right? So what does that do? You go to the register file, go through your RS and RT. Okay, so if it's R format, I will use both, right, as an operand, and then go through the bus A, so that you prepare the input for ALU. Okay, so this is ID's job. Okay? Decode and prepare your data. And if it's I format, you have RS and immediate, right? So you use RS and immediate. So you need to extend your immediate so that it becomes 32 bits. And then remember this, your Xbox and PlayStation, you have a TV, so you need to choose which channel to turn on. So when you turn on one channel, the other channel will be blocked. So it doesn't matter what is presented in front of it. Okay, so this is ID stage. What is the third stage? Third stage will be the ALU stage, right? ALU stage is very simple. all you need to do is just to do calculation. That's all. Okay, so this is ALU. Okay. Oh, I really like to have a touch screen with the lecture. It's all easy. Okay, so now I have the ALU. What does ALU do? Take in the two input. So with ALU, it doesn't really care where you get the input now, because when the time starts for ALU, it just takes the copy of these two input and do the calculation. It no longer cares about whether it's from RS, RT, or immediate anymore. Okay, so you can see that this is kind of like an assembly line. Okay, at the end of each assembly line, you will provide the input for the next assembly line. Okay, so you don't care. What it cares is what kind of operation, because it is kind of like a computer, right? So it can do all sorts of arithmetic, right? Add, subtract, multiply, divide, and also do some logical, like and, or shifting, right? So, and then you can also do compare. So when you do compare, actually it's do subtraction, right? So that's how you do the comparison. So when I do comparison, make sure that you use subtraction. Okay? Because when you do the subtraction, the result is 0 means it's the same, right? If the result is not 0, it's not the same. Okay? So when you do the branch, this is how we do it. Okay? And if the result is a negative, then you know that the first number is smaller than the second number. When the result is positive, then you know that the first number is greater than the second number. So you use a subtraction to do the comparison. Okay? So this is ALU. And what is the next stage? Memory, right? And what does memory do? Low word or store word. So if the instruction is not low word, store word, you don't need to worry about it. Okay? So which means that during this stage, you just take a nap. You are idle until the next stage. Sounds good? So if I have add I, if I have add, if I have shift, then memory stage is idle. But if I have low word, store word, then I have a memory stage. Okay, so where's the memory stage? This is the memory stage. Actually, let me include the marks for the memory stage. Okay, so this is your memory stage. Okay, what does it do? Memory stage takes in the output of your ALU. Why? You can see that there's a line here, right? So why? Think about the low word. What do you do with the address? You need to add the immediate to your base address, right? And that's your final address. And this is what the ALU does. You have what? The base address from the register. You have the offset, right? The one outside of your parentheses. So this one is within your parentheses, right? In the lower. And this one is the offset, right? So you add them, and this is your final result. Okay. But the result is not what you want to store, right? You want to use it as your address and then get your data. So this is lower. If it's a store word, you still use this address and then copy the data from RT, right? And put that into the data memory. So this is what memory stage does, okay? So if it's a low word, now you have an output because you're loading something to a register, right? And then you need to turn on a signal for your memory to register to 1 so that it will go out. Okay, so again, this is like another TV, right? PlayStation and Xbox. And in this case, if it's a low word, you want to turn on your Xbox so that the data from your memory can go to the register. Sounds good? All right, so this is memory stage. And finally, and also here, you have the memory write. Are you writing into memory? So when you don't write to the memory, make sure you turn it off. Otherwise, anything from here will pollute your data. Because again, this is kind of like a electronic devices or digital devices. They are kind of like a water pipe. Okay, if you don't shut it off, things will go into your tank. Okay, so this because constantly there are data here. So in the whole circuit, there are electrons or data going over everything. Okay, all the lines are populated by electrons. Only when we use certain control to block it, that it won't go into the device to pollute the data. So this is very important. And later on, we'll talk about the register too. Okay, so now if I'm doing low word, I'm not writing into the memory, right? Low word is to get something from the memory to read, right? So I will turn off this so that the data from here won't pollute it. Okay, so remember that. Only when you do store word, this one is turned on to be 1. Okay, okay, so this is memory. So now, last one is write back. What color can I use? Let's use orange. Okay, so write back is what? Write back is, again, write back is write back to a register. So it will involve register, but on this portion. So this is kind of messy, huh? So where should I put it? Let's put it here. Write back, okay? Or register write, sometimes I say, okay? So it depends, okay? Register write, write back is the same thing. Okay, so let's be consistent because I think in the lecture I use register write. So, okay, is register write, okay? Doesn't really matter because in your CSE 140, we started to use write back instead of register write, but it's the same idea, is to write back to the register, okay? All right, so what does it do? So you get a final result, right? Either from the memory or from your ALU. You go to the register, and now you need to write into the register, right? So you need to write into RT or RD, depends, right, of the format. So your data will be in bus W, as we mentioned, right? Bus means that you have a whole bunch of data, a whole bunch of bits at the same time, going at the same time, right? So that's why it's called a bus of student, right? And go into RW. The W refers to your bus name. So now you have 5 bits. Okay, which one? Okay, so 5 bits to talk about R, right? You have 5 bits, 5 bits, 5 bits, right? So it depends on the format. If it's I format, you write into RT. So you turn on register destination as 0. If it's R format, you write into RD, right? So now the channel of this TV is 1, which means our register destination is 1. And make sure you turn on the register write so that you can write into a register. Okay, so you turn on the faucet, the bus will go to your register. If this is 0, you are not doing anything in register write. For example, store write. Okay, so this is the 5 stages run through. Sounds good? So hopefully by looking at this colorful railroad track, you see the 5 stations of your railway system. Okay, instruction fetch, decode, ALU, memory, and then write back. And once it's done, you would decide whether to go to the next line or a branch. We talk about this branch, right? Because it's what? Your immediate plus your next line. Remember how to count? You start counting from your next instruction and then add your immediate, and that's your final destination of your branch, right? If you take the branch. So which means that if you take the branch, you want to allow this channel to go through. So I should have a label here, 0 or 1 here to make it clear. Okay, so in your exam, I will provide all the 0s and 1s so that you know which channel to turn on. Even the extender, 0 extender or the sign extension. Okay. Okay, so here is another overview of the data path. I have my simplified data path, actually the whole thing. It should be including this. Okay? And then I have my control. Okay, so the control will be covered in the next lecture. How do you control is basically activated during the instruction decode stage. Okay, so when I decode, I will read the instruction, right? And then know what signal to send to the data path to turn on those muxes. Okay, so that's the control's job. All right, so now let's find out the control signal. And this is very important, right? So this is pretty much the simplified version. So you can see that this is instruction fetch unit, which means that it includes these. Okay, so this is different, right? So this is instruction memory. Okay, And instruction fetch unit basically is the whole green thing. Okay, so let me use a green pen to highlight that. Okay, so this is the whole big chunk. So which means that the whole block of the instruction fetch unit, okay, is inside this square now. Okay, so that's why you have an MPC select and clock. Okay, and then your decoding stage, right? And then you have ALU, memory, and then your register right back. Okay, so now let's take a look at all these control signals. Right. So in your exam, all you need to do is to be able to find out whether these are ones or zeros, or in this case, it's not just one or zero. It's an exact operator that you're gonna do. Okay, so I'll use some examples to go over that. So don't worry about that. Okay, so giving you an instruction. Okay, how do you trace the path, right? And then by tracing the path, you know the channels to turn on. Right? And I want you to be able to tell me which channel to turn on for each particular muxes. Okay, so I have several control, right? I have this one to turn on. I'll talk more about that. To turn on that, which one is your next PC select, right? So which one will be your next PC? +4, which is the next instruction, or the branch target. Okay, so I'll talk more about that in an example. Okay, and then for decoding, which channel to turn on? Am I using bus B's value or the immediate value? So I format or R format, right? Okay, and if I'm using immediate format or the immediate value, how do I make this 16 bits immediate into 32 bits? As I mentioned, right? We cannot encode 32 bits immediate inside the 32-bit instruction. We don't have space, right? So immediate is only always 16 bits. So how do I make it into 32 bits? How do I extend? Do I add all zeros in front of it or add all ones in front of it? So you need to double check with your MIPS sheets to do that. So make sure you have your MIPS sheets ready for your exam. Okay. And then for ALU, what kind of operation? Is it an add, subtract, or and shift? Okay, so all depends on the operator. And then for memory stage, am I writing into a memory? If I write into the memory, you turn on, equals to 1. 1 means on, 0 means off. Okay, so remember that. Okay, so when I do low word, do I need to turn on? Low word is what? Low word is to read, right? So I'm not writing, so I will turn it off. Okay, so that's what the memory write is. And then am I allowing the ALU output to go back to the register write, or am I allowing the data from the memory to go to the register write? Okay, so this is the job of your memory stage, memory to register. So do I do low word? If I do low word, this is 1. If I don't do low word, then the output will be 0. Okay. Now, what about store word? Store word, do you want to let this pass through? No, right? Store word doesn't read this one to write into register. Store word doesn't read this one as well, because store word ends at your memory stage. It doesn't do memory write. I mean, it doesn't do register write, right? So we don't actually care. Okay? And when we are not care, make sure that your register write is off, to turn off, so that it doesn't matter which channel to be on, the register write signal will block it. So by turning it off, you don't really need to care. So you will see what to do with it. Don't care. Okay. So, but if you need to write into the register, then you need to turn it on by setting it to 1, and then now decide which channel to write into. Am I writing to RD or writing to RT? Depends on the instruction, right? Okay. So let's do one by one. Okay. So let's zoom into the instruction fetch unit again. Okay. So I have a NPC select. which means that I need to control a mux. And the mux will determine to turn on channel 0 or turn on channel 1, Xbox, PlayStation. Okay, so you have your current address. So I fetch my instruction using this address. At the same time, remember instruction fetch, you will add 4 to it. So by the end of your instruction, your PC actually has a new value. Okay, but that doesn't mean that it will be your next PC, because we don't know what instruction we're gonna perform yet, right? If it's an add or subtract or any arithmetic, then yes, you will use this. Okay, you will set this to 0. But if it's a branch, then it will depend on whether the branch statement is true, and I need to go through that. Okay, so I'll use an example later. Okay, so NPC select will choose either +4, right? Why +4? Because you have a +4 here, or the branch target. So it would be the new PC is your PC +4, right? Your PC +4, and then plus the sign extension. So which means that you need to have a sign extension of it, and add to your PC +4 and choose this channel when your branch statement is true. Okay. All right. What about the rest? So I kind of talked about that already, right? So for instruction decode, I have the extension operation, which means that what kind of extension you want. Okay, you have sign or unsigned. Unsigned means 0, which means that what? If it's a 0 extension, which you just treat it as unsigned integer, which means that there's no negative. When there's no negative, you just pad the number with 0, right? So the example is you have your immediate, right? And then for unsigned or 0, you have all zeros. If you have sign, okay, you have either, okay, where y equals to 1 when is negative, y equals to 0 when is positive. Okay, so this is sign extension. Okay, so you need to choose. So read the MIP sheet. MIP sheet tells you how to do the extension, just like here. Okay, so that tells you whether you use assigned or unsigned. And I will specify. Unsigned, usually the control is 0. Sign control is 1. Okay, so you have 0 or 1. Okay, so all the controls will be either 0 or 1. All right, so remember that 0 or 1. 0 or 1. Okay, so for the right, except for the ALU control. ALU control will be with the actual operator. So you need to tell me the actual operator. Okay, all right, so now you have the extension. After you have the extension, the next thing is go through the extension. Now your ALU source need to choose which one to go through. Okay, am I allowing the bus B to go through, which is the register B, RT, or am I allowing the extended version of your immediate to go through? So this is the job of ALU source. So for our format, of course, bus B always, right? But if it's I format, depends. Regular arithmetic, yes, you will use ALU source 1. But if it's a branch, later on we'll see, you need to use both to compare. Okay, so this is the ALU source. In ALU control, as I mentioned, is the control of your operation. So that's why 0, 1 won't work, because I have more than 2 types of operations, right? So in that case, I'll expect you to actually write, I'll give you a choice at that time. Okay, so I'll give you a choice and then you just write down a number. Okay. Now you have the address or the result of your sum. If there's a memory stage, then it will become your address, right? But remember, if it doesn't write into the memory, if your instruction doesn't write into memory, turn it off. Otherwise, you will pollute your memory. which is not good, right? So if you have store word, turn it to 1 because you're storing what's from the data in to your memory. Everything else, turn it off, even if it's not related to memory. For example, add I. Does add I do anything with the memory? No, right? Does add I need to write anything to the memory? No. Then you turn off to set it to 0. Sounds good? So remember that. Doesn't mean, so which means that even if an instruction has nothing to do with your memory, like add I, add, or shift, you will make sure that your memory write is off. Okay, because when you, for some reason, turn it on, you allow whatever is in this pipe to go in, which is the no. Okay, so unless you want it to go in. Okay, and then next is your memory to register. Very easy to remember. Are you allowing memory to register to happen? Okay, if it's true, turn on. Okay, because then you're doing load word, right? When you do load word, you load something from the memory and go to the register, right? So basically you ask yourself, am I writing something from the memory to register? If it's yes, turn it on. If it's no, you allow this line to go through. For example, the regular I format arithmetic, right? Now the data will go to here in your bus W. The next thing is, am I writing to a register? Is it a dumb question to ask? Is there a case where you don't actually write into a register? Any instruction? Store word, right? Store word does not write into a register. Store word is what? Copy something from the register into the memory, and that's it. Okay, so, but most of the instructions are writing in the register, right? Add I, these are writing in the register. So if you don't need to write into register, again, turn it off. Otherwise, you are polluting your register. Okay, so write is very important. So whenever you don't need to write, turn it off. Okay. What else? What else don't need to write into register? A branch statement. When you compare the two registers, then what's next? You just go to the target, right? You are not writing anything into register. What about jump? Same thing, right? Once you decode, you know this is a jump, you jump to the target. You don't need to write to the register. So you will set the register right to 0. And anything else, if you need to write into register, you set it to 1 and then determine which channel. Am I writing to RD or RT? Depends on your instruction format. So far so good. So these are the control that I would expect you to be able to tell me in your exam. Giving you an instruction, and what are the values of this control? Okay. So again, I'm not asking you to write a digital circuit to talk about the design, okay, to make a decision, but actually go through this data path from first stage, instruction fetch, all the way to 5th stage, okay, register write back. Okay, what are the control value? Okay, so to do this, I'm going to use some examples, right? The easiest way to do it is ask yourself questions. Okay, by asking yourself questions, then you know the answer. Okay? So then your answer will give you the answer to your exam. Okay, so keep asking yourself, what are you supposed to do in this stage? Okay, whatever stage you're in. All right, so let's use one example. Add I. Add I is what format? Our format, right? So I have 6 fields. And what do I do in the first instruction? I mean, first stage. Okay, fetch the instruction. Okay, your PC. So by now you should understand what PC is, right? PC is just your address to your memory. That's all. Okay, address of your instruction. So this is called PC. Okay, so go to the PC, okay, of the memory, grab that, and then decode, right? So from your MIP sheets, you know this is how you decode. All right, so what is the instruction fetch? Very straightforward, right? You have your PC, go to the memory, grab the instruction. That's all, right? And then prepare your next PC. So this is instruction fetch state, right? But you don't go out yet, right? So you have your original PC plus 4, but you stay there because you are not ready for your next instruction. And then now the real data path. What do I need? What is decoding stage do? Decoding stage will understand what it is, right? So what do I need? I would have, this is our format. I would need RS, RT, RD as my information, right? So which means that I will need RS, RT, RD, right? And then what? What is the decoding stage? Where is your decoding stage? Here, right? This is your decoding stage. Get the data ready. So I will need RS, RT from the operand, right? So go into the register file, grab them, and prepare them as the input of my next stage ALU. So here, what do I see? I have channels 0. Okay, so I will allow channel 0 to turn on so that bus B can go through. Do I need to worry about the immediate? No. So I put an X here. So X means I don't care. It can be 1 or 0. Okay. So this is called don't care. Okay. Next, so this is pretty much your decoding, right? And then what's next? You have ALU stage, right? ALU stage is what? What are you doing? You are doing add, right? So whatever you have in bus A, add to bus B, and you have the result. And so the output will be add. So in your exam, probably I will give you a mapping. Maybe A add equals to 0, and then B sub is 1 and is 2 or is 3 and so forth. So you just need to give me the number instead of typing the actual operator. Okay, so just read the questions carefully. Okay, so now I'm done, right? So I will have add and produce a result. And does the result go to the memory as address? Does it go through here? No, right? Because I'm not writing, I'm not doing memory access. This is an add, right? So remember, so always ask yourself question, what am I doing in this stage? Referring to your original operation. So at this stage, ALU will bypass the memory and get ready for your register write stage. Okay. So what's next? Since this has nothing to do with memory, I will allow the result of my ALU to go through the mux. So my memory to register is 0. And since I'm not writing anything to the memory, make sure that you turn off. Otherwise, you pollute the data, right? And then now I'm in the register write stage now. So now what's next? Am I writing into register? Yes. Okay, so I turn on the write. And which channel do I write to? RD or RT? RD, right? So channel 1. And that's my data path, right? And now I'm done with the 5 stages. Go back to your instruction fetch. And where should I go now? Am I allowing, so where should I get my next instruction now? So I just finished add. Where is the next instruction? The next line, right? It doesn't go to branch. So I would shut off this channel and pick this one, right? So PC select is 0 so that I am allowing the PC plus 4 to go through. Now we have a new instruction. Sounds good? So now it goes through, you have a new PC for the next clock now. And then the same 5 cycles repeats again with different instructions. Sounds good? So now I have a new instruction. Okay, so you have new address, and then you get a new instruction. And then you repeat this same instruction fetch, decoding, execution, or ALU, and then register write, and over and over. Okay. So now let's see. My next PC gives me this instruction. What is this? Oops, I don't want that. What did I do? Okay. Okay, so I have a new instruction, an OR operator. Okay, so if you look at the MIP sheet, the OR operator, be careful, is a 0 extension. Okay, so which means that you need to pad your 16-bit with 0 in front of them. Okay, so always refer to your MIP sheets. All right, so what do I need for this one? Oops, let's do it together. Okay, so instruction fetch, you will fetch the instruction, right? And then get your PC, so it's inside the unit, so I cannot do anything, right? Next, I will have what? Decoding, right? Decoding, where do we start? I have RS and immediate. So I'll have RS, go to bus A, immediate, right? And what kind of extension do we need? 0 extension. So I'll put a 0. So again, I'll give you a choice, okay? So instead of writing the word, I'll give you a choice, okay? So now, which means that what is the ALU source? I want this to pass through, right? I want this channel. This is my Xbox. Okay, so I will have 1. Sounds good? Okay, so again, ask yourself every stage what you are supposed to do to get the right result. Okay, so I'm in the decoding stage. I'm done, right? And then what is the next stage? ALU stage. So now I have the 2 inputs. What is the ALU stage doing? The OR operator. So I'll have an OR here. Excuse me. So it will produce the result. All right. So far so good. So this is our ALU stage. And what is the next stage after ALU? Memory stage, right? And this is an OR operator. What am I supposed to do during the memory stage? Take a nap, right? So we don't do anything. So again, the output doesn't go to the address anymore because it has nothing to do with the memory. And because of that, make sure you put a 0 in your memory write. Okay? And what's next? Memory stage ends and then goes to the register write back. So are you writing back in the register? Yes, right? So which means that which channel do you want to turn on so that you have the correct value to be fed into the register? Channel 0, right? So now I let it go. Go back to here. Am I writing into register? Yes, right? And then to what channel? Write back RT, right? So I have channels 0. Now I'm done. And then where do you get your next line? Since this is an OR, it's not a branch, it's not a jump, the next line will be +4, and you're done. So you have this answer. Sounds good? So make sure that you have that. And actually, I will circle this and circle this. So you have to have all the input. Sounds good? And in this case, MPC select is +4. Okay, or channel 0 if I give you a label. Okay, so this is all. All right, low word. Okay, so how do we do that? Same thing. So if you look at the MIP sheets, you see all the stuff, right? Go to the memory, grab the data at the sum of this address, right? So I need what? Instruction fetch. And what do I get? I will need RS and immediate. So this is decoding, right? And what else? In the decoding stage, how do you prepare the data, right? So I need RS to go through bus A. So this is my base address. I need immediate 16 to go through, right? So from here, I can see that I need an extension, right? What kind of extension? Sign extension. And with the label, I will use 1. Okay? So which means that depends on the sign. If it's positive, I add zeros in front of them. If it's a negative, I'll add ones in front of them. Okay, so be careful. But you don't need to do anything. Just pick the control signal. So I'm not asking you to actually do the extension, right? So now from here, we can see that I'm allowing channel 1 to turn on, right? And then what's next? So the next stage is ALU, right? You provide the input. What does the ALU do? Go to the memory? No, right? ALU is do what? Adding, right? So you add. So this is your job. So the operation will be add. Okay. And now you're done with the ALU stage. What do you do with the ALU stage? Are you sending them to the register or access the memory? So again, don't have too much fun playing with this choo-choo trick and you forgot what you're doing, okay? So here we're doing lower, which means that I'm dealing with memory, right? And I'm reading or writing. Lower is reading, right? So, which means that I will have a 0 here. And I will use the sum from the ALU to access the memory. So this is my address, right? So the sum is the address. Okay, so now the ALU, the memory will give you a data because this is reading, right? Load the data based on the address, and then that's what you want to bring back to the register. So the memory to register is 1. Okay. Am I writing from memory to register? Yes. So that's why you have 1. Okay. So now, am I writing anything to the register? Yes, right? Because you have a write back. Okay. So it's 1. So go through here. Which channel? I'm writing to RT, right? So I have a 0. And you're done. And where do you go to the next line? Are you branching? Are you jumping? Maybe you're jumping physically, right? But no, you're not going anywhere but the next line. So you have a +4, or just choose a 0 again with the label. Any questions? So you have all the control ready. Okay, so you have sign extension, the source is 1, and you have add, you have register to memory to register, you have memory write to turn off, and then you have register write is turned on, destination is 0, and your next PC is +4. Okay. Now let's do the store word. So very similar. Store word is the other way, right? You write into the memory. So data goes into the memory. Okay. So what is your first stage? Instruction fetch. And then decoding stage, since you know that this is an I format, you have RS, RT, immediate, right? And then in the decoding stage, what do? You have RS with the base address, immediate, okay, with the offset, right? So you have a store word, RT, immediate, RS, right? So now you do the extension. What is the extension? Sign again, right? Or a 1. And then now, which source do you want to set? Channel 1. Okay, so this is decoding stage. And what is the next stage? So you can see, right? Pay attention. If you cannot tell, rewind the video and observe how I ask questions. Okay, so when you're in one stage, ask yourself what you're supposed to do within this stage. And then when you're end of this stage, ask yourself what stage are you going into. So I'm just done with my ID stage, decoding stage. Where should I go? ALU stage, right? So now ALU stage, I have my input. What do I need? What kind of operation? What kind of operation? Add. Okay, so I'm done. So after a while, your add will produce a result. So this is the end of my ALU stage. And what's next? ALU stage, next stage is memory stage. And what do I do is with the memory? Do I need the memory stage? Yes, because it's a store word, right? So when I need to use memory, what do you do with the result of your ALU? So this is the question you asked, right? So the result of your ALU goes into the address because that's the address, right? And what's next? Am I reading or writing? Am I reading or writing? Store word, I'm writing, right? So I will have one. I'm writing into the memory. From what? From this RT, right? So RT is where? RT is here. Bypass the marks and go to here. All right, so let me use another color so that you can see clearly. So RT, we go to bus B, but not into the marks, but go to the data. All right, so that's your memory stage. Okay, and then what's next? Am I writing the data to the register? No, right? Because I'm writing into the memory, right? So I'm not reading anything from the data memory. Am I saving anything from the ALU to the register? No, right? So actually, in this case, I don't really care about which channel to turn on, right? For this one, so I put an X here. Means don't care, which means that it can be 0, it can be 1. That doesn't matter. But I would prefer you to put an X there so that I know you understand why it doesn't care. Okay, why? Because you don't have the fifth stage. Right? It doesn't write back to register. So what does that mean? I turn off this so that whatever pass through this, either 1 or 0, will be blocked by your register write. And because of that, do you care about what to write into the register, RD, or which register to write to? No, I don't care. Okay. So next, after this data storage, okay, the store word, what's next? Where do I go for the next instruction? Don't care? No, you cannot be don't care. So it will be +4 again, or choose a channel 0. And that's your store word. All right, so I'll highlight again. Add, you have sign extensions, the source is 1, right? And then you have data in, and then since you don't have anything to write back, your write back is 0. And since you don't write back anything, your destination is don't care. And then finally, you add 4 to it. Okay, so this is your store word. Okay, so how about branch? So branch is a little bit tricky. So let's take a look at it. All right, so here, what do? I would do subtraction to check whether they are the same, right? So basically, what you need to do BEQ, let's say, then your 0. Okay, so 0 is here. Okay, so BEQ, RS, RT, and then target, right? So basically, it's a PC plus 4 plus your immediate. That's how you get it, right? So, okay, so how do we do that? Instruction fetch. Next, then we'll have, since this is I format, I have RS, RT, immediate. But now, do I use, so I know that I'm going to use RS, right? But do I use immediate here? Is the immediate used for calculation of your comparison? No, right? Immediate is used for your target address. So what is the comparison here? I'm subtracting RT's value to RS. So which means that this is a special case. Okay, so you use both RT and RS just like your R format here. So this is a very special case. Remember that, okay? And what's next? So which means that I don't really care with this one, okay? Because I'm not using this. And ALU source will be 0 because I use bus B. And the output, I don't actually have output here because the output has nothing to do with the rest of the data path because it doesn't go back to register write, but I have an output here for the 0. Okay. If this is true, this becomes 1. If this is false, it becomes 0. That's all. And it will control the instruction fetch unit to whether go to this target or not. All right. So this is control by 0 or equal. Okay, so if it's equal means that the sum, the difference is 0, right? So that's how you control that. Okay, so this is the path. Okay, so far so good. And then I don't know yet, so this one is called branch. Okay, so in this case, since I don't involve anything after ALU, turn it off. I don't care. Okay, I don't care. And then turn it off. I don't care. Okay, so now what is the branch? Okay, so this means that it has something to do with your equal. So first of all, is this a branch statement? If it's not even a branch statement, what do you pay? Next PC, right? But if it's a branch statement, now it depends on this now, whether it's true or false. So which means that I need to do some circuit design again. Okay. So I know that I have a regular next PC, right? I have my current PC at 4, and that will be your next PC if it's not branching, if it's not a jump. Okay? But what about it is a branch statement, right? So here, this tells you whether is it a branch statement, true or false, right? If it's not even true, you don't really care. Now you just turn this channel to to 0, and you have the PC plus 4 to go through. Okay. So now let's consider some logic. So how do we put this? Okay. So what kind of logic do you need? Okay. So what is the mux select? Okay, so I should say this should be okay, instead of NPC select because you have that here, right? Okay. So first of all, is it a branch or not? If it's not even a branch, just go to the next line, right? So, and then if it is a branch, doesn't mean that we will take the branch, right? Because you have to test first. If it is 0, which means that the subtraction gives you a 0, you have a 1 here, okay, because 0 is true. So you have a truth table. Okay. So if it is not a branch, not a branch, then I don't really care about whether the result is 0 because it's not a branch, right? So I will turn off the mux. Okay, but okay, I will turn off the mux. But if it is a branch, when this is 1, now I need to decide whether it is true or not, right? By using the subtraction. If it turns out that it equals to 0, which means that it's true. If it's true, I need to turn on, right? So this is true. This take the branch. Okay. So is it a branch, right? So this is basically not a branch, right? Okay, so what kind of logic gate it is? Everything is 0 except when both are true. And gate. Okay, so this is how you design, right? So when it's 0, you don't really care because the output is 0. Okay, when it's 1 and then the equal is 0, which means that it's false, you still go to the next line. Only when this is a branch statement and the branch say the comparison is true, now you take the branch and it becomes 1. Right, and this is the last case. All right, so this is the end, and that pretty much gives you what you need for your exam on Saturday. Okay, so doesn't mean that the next lecture is not important, okay? But the next lecture, we'll go over the jump, because we haven't touched the jump. But most likely, I'm not going to ask you jump in your exam. So just study this video, okay, really thoroughly, to be able to trace all, if not all, at least most of the instructions in your MIP sheet. So pretty much from this video, you should be able to trace most of the instructions from your MIP sheet. So practice that before the exam. Just pick 3 to 4 from each format, right? 3 from our format, 3 from I format, and then with some branches, and then to try it out. Okay, so I'll hold an office hour on Thursday, okay, between 10:30 and noon, and I'll send out an announcement to you. Okay, all right. So study hard. Just few more days, and after that, you're done, right, with the semester, and you deserve a good break. And you guys are really doing well. So, and doing very hard, I can tell. Okay, so, and I'll think about what to do with your first online exam. I know I messed up, so I may give you a shorter version of it to do the retake and add the result to your previous one. So stay tuned. I'll make an announcement.